Welcome back to Math is Easy, step by step. So here in this particular problem, we're trying to find the diagonal length of rectangle P, Q, R, and S. And I've used some of the values I showed you on the part 1 video and to show you the length between R and S, right? Showing you that length is 6 units, right? Showing you that from P to Q is 6 units, right? Sides opposite in a rectangle are equal to each other. And we have length R, Q line segment is 4, and so for P to S, that unit length is also 4. I've also shown you that in each of these corners of the rectangle, by definition, we have a right angle. That allows us to use Pythagorean theorem, which I'm going to show you in this part 2 video, how to use and follow Pythagorean theorem. So you can see why labeling up the sides, of course, P to R is our hypotenuse, our C value, which we just don't know. And that's what we're going to use to solve to find the length of the diagonal P to R. And then in the second video, and for the reasoning I'm showing you the labeling here, is we want to find the distance between P to R using the distance formula. Didn't want to distract you, so I have that blocked out for now. But in the next video, part 3, I'm going to go over that. So I'm showing you here the X and Y values for P, the X and Y values for R. Simply put, P was the first value for X and Y that I put on my paper. So I just label that X1, which makes it automatically Y1. Okay. And then R values makes X2 and Y2 from the ordered pair. Because I've already labeled these 1 and 1, that makes these values 2 and 2. And I just organizing these values, so I'm going to substitute them into a formula in the part 2 video. So go ahead and label up. If you have a problem like this, listen, you may not have lined graph paper, but you can just draw a generic X and Y axis, label them the best you can in equal distance of 1, 2 through 10 or 1 through 10, and then plot your points, and you will get an answer if it's not exact, similar to allow you to choose A, B, C, D, or an E. So I labeled my leg here on the left side A. I labeled my leg at the base here B. You could do vice versa. You could label this B and label this A. Just make sure the values, as you can see here, the S to P or P to S line segment is 4. So we're going to label that 4. And then the S to R or R to S is 6. So we label that 6. C, our hypotenuse, which is always opposite that right angle, which is represented by a square, is unknown. So I'm going to use the Pythagorean theorem down here. And this particular triangle to fill in the missing values. I'm going to take it step by step. I don't want to confuse anybody, so stick with me. The formula C squared equals B squared plus A squared can also be written A squared plus B squared equals C squared. So you can kind of reverse this, or you can put A squared here and B squared here. What's important is that C squared is all alone on one side of that equal sign. Here, our C squared, our unknown, is line segment PR. So I put a square next to PR. You don't have to do that. You could just use the C squared. I just want to do this. And I've organized my A value, my B value, and my C value is unknown. Simply, you're going to take the value for A and substitute it for A, like I'm showing you here. 4, substitute it for A is now 4 squared. Plus, plus, B, my value for B is 6. So I'm going to put a 6 here everywhere I see B. And now that's 6 squared. C squared, I just don't know. Or my PR, the length of my PR value. And so I want to show you here, 6 squared is 6 times 6. 4 squared is 4 times 4. I just rewrite the plus, the equal, and the c squared. Okay, and I'm just going to continue to simplify with each step. 6 times 6 is 36. 4 times 4 is 16. And then everything else, of course, I just rewrite. So when you add these two values together, you get 52. I'm almost finished with this particular problem, but c is not alone, right? I have this square, power of 2, attached to the c. I need to get c all by itself. So what's the opposite of a power of 2? It's a radical. So I'm going to take a radical to both sides. That'll free up my c value. So I'll have, excuse me for the shaking, I apologize. I have c squared under the radical. I have 52, which you do to the left side. You got to do to the right side. C squared is c times c. I have a perfect pair. I can pull out one value of c. And I have 52 underneath that square root. Now, I want to try, and it's difficult if you don't have a scientific calculator. You may have to do this manually. But I want to try to do my very, 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 very best to find out if 52 has a perfect square. And, the closest to 52 is 49. I know that's 7 times 7. So 49 would be a perfect square. I'm 3 off from that here with 52, square root of 52. So 8 times 8 would be 64. So not a perfect square value. I'm going to leave this in the form of c equals 52. And if we take a look here at the original option, D, square root of 52 would be the answer for this particular problem. Hey, stick around with me. I'm going to go over part 3 and show you how you could use the distance formula in order to answer this particular question. And then you're just going to have to choose which method is easiest for you. Hey, thanks for joining me. Math is easy. Take it step by step. Please, if you think it's appropriate, like and follow and share these videos. If I've helped you, please help me to continue to come to you and bring these videos for you and others by donating your gifts, your stars. Thank you so very much. Math is easy, step by step.